Good evening, all of you. Today is Science and Technology class number 3. In class 1, we had started with the Indian space program, in which we broadly looked at topics like what is ISRO, what is the vision of ISRO, and what is the role of ISRO chairman. And we also discussed that he is the de facto Secretary of Department of Space. We looked at the organization structure of ISRO. Before that, we also looked at some of the major launches done by India, starting with 1975 Aryabhatta. And then we touched upon this SLV-3, which was India's first satellite launch vehicle. We looked at a major timeline of ISRO in terms of what were all the key milestones, starting with Aryabhatta, Bhaskara, Rohini. Then we also, in the second half of the class, I also touched upon the INSAT series of satellite, the PSLV, the GSLV. We have launched satellite to the moon not once but twice. We have successfully developed our own cryogenic engine. We also had this Mars orbiter mission, and we saw that the two really trustworthy launch vehicles of ISRO are PSLV and GSLV. PSLV, in fact, in 2017 had held the record for launching 104 satellites in a single rocket launch. At the same time, we also discussed the importance of GSLV, which is the real workhorse of ISRO. Why? Because it is this GSLV, especially GSLV Mark III, which is going to take human beings to space, that is Indians to space. It is also, to that extent, is considered as a heavy lift kind of launch, because it can lift up to 4 tons if it is if the orbit is geostationary orbit. It can lift up to 10 tons if the orbit is low Earth orbit. We looked at the organization structure of ISRO, especially the role of Space Commission and who all constitute the Space Commission. And we also looked at some of the key agencies of ISRO, right from the research facilities, the test facilities, the construction and launch facilities, so on and so forth. Yeah, and we looked at the importance of each and every facility as far as ISRO is concerned. The last part of the organization was about antrics, and and in antrics we also had talked about this unfortunate fallout of the antrics Devas deal, which was in news recently because of the Supreme Court judgment. Then we looked at a little detail into the type of launch vehicle, which we have already discussed. PSLV is the Polar Satellite Launch Vehicle, which launches satellites in the Sun synchronous orbit. GSLV is the geostationary orbit, which launches satellite in either the geostationary orbit or the geosynchronous orbit. The difference between both we had discussed. From the launch vehicle, we moved on to the type of orbits. Yeah, starting with the low Earth orbit. So low Earth orbit, we discussed that anything less than 200 kilometers or less is a low Earth orbit. But even in low Earth orbit, generally the objects, the orbits are not below 160 kilometers, because placing them at 160 or below increases the orbital decay, which is due to the atmospheric drag. We also said all the human space flight have taken in low Earth orbit. The International Space Station, which is at around 400 kilometers, is in low Earth orbit. Low Earth orbit obviously has lower launch cost because you need that much less fuel. And we also had certain disadvantages of low Earth orbit. One disadvantage of low Earth orbit was this small field of view. If you can imagine, this is like, someone going up the building, which is, let's say, 10-story, he will be able to see only limited height. But if someone is able to go to a building which is 100-story, he'll be able to see a larger view. The same is in the case of low Earth orbit. So from low Earth orbit, the satellite can only have a limited view. As a result, whenever you want to launch a satellite in low Earth orbit but want a complete 360-degree view, then you usually launch a constellation of satellites. Okay. Then came your Sun synchronous orbit. In Sun synchronous orbit, there were 2 key points. One, the Sun synchronous orbit is usually the polar orbit. That is, unlike the geostationary orbit, where, or even some of the other satellites in low Earth orbit, like International Space Station, which orbit along the direction of Earth, that is from west to east. In the sun synchronous, in the polar kind of orbit, the satellites orbit in the along the poles in the north-south direction. Now, why is it called sun synchronous? I gave an explanation, and we also drew a map to prove that. Sun synchronous means the satellite appears exactly at the same point at the same local time on the planet Earth. Okay, and typically these satellites have about an orbital period of around 90 minutes. The satellites which are in the sun synchronous orbit, as a result of which they're able to make anywhere between 12 to 18 kind of rotations around Earth in a single day. The last kind of orbit is the geostationary orbit or geosynchronous equatorial orbit. So geostationary orbit is the height above the Earth at which the satellite appears to remain stationary because its rotation around the Earth is exactly the same as that of the Earth's sidereal day, so to say, which is 23 hours and 56 minutes. And therefore, the satellite appears stationary. Therefore, the satellite appears stationary. Now, this is called as the geostationary orbit or geosynchronous equatorial orbit. There is also a normal geosynchronous orbit in which the satellite is not above the equator. The satellite is at some point of the Earth at an angle from the equator, but even at that angle, the satellite's rotation around the Earth is same as that of the Earth's rotation, which is close to 24 hours. So generally, you have communication satellites and weather satellites, which are part of geostationary orbit. We touched upon the graveyard orbit, wherein we called it as the orbit which is specifically designed to keep all the satellites who have exceeded their normal working time. So why this graveyard orbit is required? As the name suggests, this is for those satellites which are dead. And because they are outside the pull of gravity, they continue to remain in space, and that could be a danger for other live satellites because that increases the cause of collision. So just before the end of life, these satellites, by performing minor satellite maneuvers, they are helped into another orbit called as a junk orbit, graveyard orbit, or disposal orbit. One type of orbit I forgot to tell in the last class is the geosynchronous or the geostationary transfer orbit. If you look at this image, the image makes it very clear. You have three colors here. So on top of the Earth image, you have an yellow color and a blue color and a red color. Yellow color is denotes the satellite the launch vehicle taking off from the Earth, and then even though the payload is for the geostationary orbit, which is the red color, which is 35,786 kilometers. From an operational point of view, the satellites are first placed in the blue color orbit. If you look at the blue color orbit carefully, it is two observations. First, it is not circular. In fact, it is elliptical. That is the first observation that I can think of. Second observation, even if it is elliptical, the Earth is not at the center of the ellipse. Let's try to understand why. When a rocket is launched, or a launch vehicle is trying to place its payload in a geostationary orbit, it does not immediately go directly to the geostationary orbit. First, it rotates around the blue-colored orbit, which is called as a geosynchronous or geostationary transfer orbit. This is an intermediate step. As I have mentioned it clearly, this is an intermediate step. Now, what happens in this case is, why is it called geosynchronous transfer orbit? Because if you know, in an elliptical orbit, there are 2 points. One is called as the perigee, other is called as the apogee. The perigee, which is the closest point, this is in the low Earth orbit, but the apogee, which is the farthest point, that is in the geostationary orbit. So are you able to visualize? So this orbit is somewhat a fusion of low Earth orbit at the perigee and the apogee being at geostationary orbit. Now, over a period of time, so once the satellite begins to take position, after 2, 3, or couple of more rounds, The satellite forms an orbit like this. It forms an orbit like this, and eventually, after few iterations, it enters the geostationary orbit and it remains there. Okay, so that's a orbit I forgot to discuss in the last class. Then we looked at the various satellite programs, the INSAT series, how important or how it transformed India's communication landscape, especially television, Doordarshan, All India Radio, search and rescue, meteorology. There was a drastic transformation all through the 80s and the 90s because of INSAT series. Slowly, as the INSAT series satellites became older, they had to be replaced, and these were replaced by the GSAT series. We touched upon South Asian satellite, which was more of a move by India to help some of the South Asian countries, because once you have GSAT, not just India, but many of the India's neighboring countries could also use the facilities of GSAT. Currently, all the South Asian countries except Pakistan are part of this South Asian satellite. Then we touched upon the Indian remote sensing satellite, and we looked at some of the features of remote sensing satellite. The first was they are called as Earth observation satellite, and they are part of Sun synchronous orbit. And as the name suggests, remote and sensing. So being able to sense the Earth from a distance, and this distance happens to be few hundreds of kilometers from the surface of Earth. And we looked at three variety of data: spatial, temporal, and spectral resolution, and what is the importance of it. We looked at some of the important programs that are supported by the remote sensing satellites. RadarSat or RESAT is one satellite in which I introduced a key term called as the synthetic aperture radar. The most important advantage of RESAT, if you remember in the last class, is this term, all weather surveillance. Because unlike other satellites, which are which are based on optical and spectral sensors, and these sensors are impacted by cloud cover. The RESAT, as the name suggests, is the radar imaging satellite. It is based on the sound waves or the radar waves, as a result of which they are not impacted by cloud cover. And these are primarily, in Indian case, these are being primarily launched for intelligence purposes. Today's class, we will start with India's own GPS. Yes, the name of the satellite is IRNSS Satellite Navigation System. IRNSS Satellite Navigation System, also called as NAVIC. NAVIC is an acronym for Navigation with Indian Constellation. Now, what is IRNSS? Now, first the expansion. It stands for Independent Regional Navigation Satellite System. So that's the expansion of the abbreviation, Independent Regional Navigation Satellite System. And what does it do? The most important thing is this: accurate position information services. Yeah. How do we better know this as? We better know this as, in common parlance, we better know this as GPS. Yeah. I'll tell you an interesting fact about GPS, because GPS is kind of become synonymous with position services. A little bit of history about it towards the end of the slide. So it provides accurate position information services for users in India and region extending up to 1,500 kilometers from its boundary. If someone asks you what is the primary service area, and they say the primary service area of IRNSS is limited to the Indian boundary, the answer is incorrect. It is not just limited to the Indian boundary, it is 1,500 kilometers from the Indian boundary. Yeah. So look at it this way: IRNSS has two areas in terms of areas, a primary service area and an extended service area. The primary service area itself is 1,500 kilometers from the boundary. And any idea how far is extended service area? Extended service area is really massive. If you look at it, 30 degrees south to 50 degree north. Okay, 50 degree north, which means way above the northernmost point of India. 30 degrees south, way below the southernmost point of India. longitude 30° east to 130° east. This is, if you visualize it and if you try to plot it on a map, this is how it will look. So I want you guys to just focus on this area. So this entire blue box that you see over here, yeah, this is the extended area for IRNSS. And this is supposed to be India's answer to the global positioning system, or India's own GPS, so to say. So this is your extended service. The standard service is something like 1,500 kilometers away from the Indian boundary. Yeah, so you could call this as the standard service area of IRNSS, and the square is the extended service. Now this is in terms of area. Now in terms of who can use it, yeah, in terms of who can use it, there are two kinds of users who can use it. Okay, there are two kinds of users who can use it. One is the common user. When I say common user, we call it as the standard positioning services. Yeah, I may have missed writing it here, but one is called as the standard positioning services, which is for the common people. The second one is an encrypted positioning services, which is primarily for military and defense purposes. So in terms of area also, there is primary and extended service area. In terms of usage also, there is a standard positioning service and an encrypted positioning services for military and intelligence application. So the resolution of IRNSS is about 20 meters. So 20 meters is something in which you can easily figure out troop deployments, for example. Yeah. Now, is IRNSS one satellite, or is it a set of satellites? As it turns out, IRNSS is a set of 7 satellites. 7. Yeah. 4 in geosynchronous orbit and 3 in geostationary orbit. It would help if you can remember this. And I'm going to show you a picture which will help you to make it easy. Now let me show this picture for once. Yeah. So this is the view of the constellation, 7 satellite constellation. The black color, this one, 1, 2, and 3. These satellites are in the geostationary Earth orbit. So what does geostationary Earth orbit means? They are directly on top of the equator. They are actually on top of the equator. And geosynchronous orbit, now the red ones, they are the ones which are on top of India. 2 sets on the eastern part of India, and 2 numbers on the eastern part of India, 2 numbers on the western part of India. Now, please try to imagine this. All these 7 satellites are moving exactly as the same speed as that of Earth. As a result of which, what happens? All the time, 24/7, all 365 days of the year, they are able to provide information for this massive area. Are you able to see this? Now you may think, it's possible, you may think, India is well into the northern hemisphere. Why do we need a facility to watch almost till Australia? You may think, yeah, it makes sense that we go up to 50° north, because why? It covers entire of China, which is our major adversary now, and it maybe helps us to go a little towards east. Probably, maybe we may want to just have a watch on South China Sea also. But why should we go so much deep into the Indian Ocean? The answer to this lies in India's ambition in the future to test even longer range intercontinental ballistic missiles. Please note this point, because currently the official word is Agni, is the ICBM Agni is 5,500 to 6,000 kilometers. Maybe unofficially it's more, but officially that is the range. Now it's possible that we may extend this in future. Now, which part of Earth will you use to test a missile which has a range of 8,000 kilometers? Yeah. So the only area where you can freely use is maybe start from Wheeler Island and send the missile all the way this side. And when a missile is in motion, then it is in constant communication with the satellite. And Navik is able to accurately track the missile all the way up to 30° south. So there is a lot of thought that has gone into having an extended service area for Navik. Not just is it a GPS positioning system for India, but it also has an additional military application, intelligence application, and being potentially being used to track missiles which will have very long ranges in future. Now, you may think that why does India need its own global positioning system? We already have a global positioning system, but many of us don't realize that when we say GPS, global positioning system, it is a set of satellites of the United States which provides services to citizens all across the world. We don't even realize it that GPS is not the only navigational system. Russia has a system called as GLONASS. European Union has a system called Galileo. China has a system called Beidou. So there are multiple, all these major powers have their own global positioning system, and it was only felt that India should also have it. Now, India has also faced the brunt of not developing its own GPS and depending on the US. It is told that during Kargil war, when India sought the GPS coordinates of certain positions on the various mountain ranges, United States had refused to provide them. That was a wake-up call for India to realize that should a hostile situation arise again, it is foolhardy to depend on a foreign nation. It may be friendly otherwise, but you never know. Therefore, there is nothing better than having your own navigational system. Okay. Now, the other interesting part, so that's on the military application. The other interesting part is, if you look at it these days, two-wheelers, four-wheelers, many of them have inbuilt Google Maps and navigational system. If you have observed, even two-wheelers are advertising having a navigational system. Now, as per AIS 140, so AIS 140 is one of the standards for these electric vehicles, especially. They have to be NAVIC compliant as far as vehicle tracking is concerned. What it means is, just as you choose GPS, you can also choose NAVIC in these vehicles, and that will kind of help you with navigating the cities or wherever you go. And because that has been made compulsory for all commercial vehicles in India from 2019, and not just the vehicles, some of the mobile phones are also NAVIC compliant in India. Qualcomm and ISRO had recently signed an agreement in this regard. Yeah, so this was the part which I said many of us may not realize it, but GPS is actually a set of 24 satellites and land control stations, which is available worldwide for civilian use. But then when you ask it for military purposes, it may not be granted, as had happened in the case of Kargil war. So that's about IRNSS. And yeah, one thing I forgot to tell you, while these the black ones, the geostationary satellites will appear stationary, will appear exactly stationary vis-a-vis India, but these geosynchronous orbit, these 4 satellites, because they are not on the equator and they have a slightly elliptical orbit, not exactly circular, slightly elliptical orbit, and as the plane to the equator, they appear as traveling in the number 8. So this is how they appear. Means the satellite, it appears for a person at the ground. If he watches the satellite appears to be tracing the number 8, which is what is shown here. If you see carefully here, this is what is shown as 8 here. You see an 8 here and you see an 8 here. But that's not the case with the geostationary orbit. I hope this point is clear. In case you have any queries, we'll definitely discuss before we start our next class. The next satellite system that we are going to discuss is a satellite system which was designed specifically for airline navigation. And the abbreviation of this satellite navigation system is called as GAGAN. So GAGAN stands for GPS aided geo augmented navigation. GPS aided geo augmented navigation. So as it is related to navigation of aircrafts, ISRO and the Airports Authority of India had together developed this system. Now you may ask, why was the system developed? When you just now we have discussed that GPS covers pretty much all civilian use, which means all the civilian aircrafts must be able to use. That is true. But then the accuracy of GPS, okay, and the accuracy demanded by what is called as International Civil Aviation Organization, the governing body for everything related to civil aviation, that's navigational requirement is slightly of a higher order than what GPS could support. And GPS is anyway free, no? You can't ask a free person to add more feature because it benefits you. So you need to have your own satellite system, and that satellite system is called as GAGAN. So GAGAN, once again, in this case, is a set of GSAT, so geostationary satellites, and it has a quite a good range, as you can see. Yeah, so it covers a considerable part of India, almost the entire of Asia, Middle East, Australia, Southeast Asia, large parts of Africa. Okay. Now, what GAGAN does is it uses GPS as the base. That's why it's called as GPS. It uses GPS as the base, but when the output of the GPS comes in terms of coordinates, it corrects those GPS errors. So GAGAN does not replace GPS, as the name suggests. That's why it's a GPS aided geo augmented. So there is GPS signal and there is augmentation of the signal clarity, accuracy. Now, what causes the signal errors? It is generally said that signal errors are caused by ionospheric disturbance. We all know ionosphere, charged particle, and these sometimes interfere with satellite communication. So GAGAN is a superior version which uses GPS as the base, but does more calculation improvements, enhancements, so that it can adhere to the demands of International Civil Aviation Organization's navigational requirement. I hope that is clear. Now, currently what we have is we have a navigation system for all phases of the flight over the Indian airspace. So this Indian airspace is also in their parlance, in the civil aviation parlance, is called as flight information region. So we have navigation system for all phases of flight over the Indian airspace, also known as the flight information region, and in the adjoining area. The range of GAGAN is shown in the map. GAGANYAAN. Now that completes, we started with INSAT series, moved on to a couple of them, and today's class which touched upon IRNSS and your GAGAN. Now we touch upon what is perhaps the most ambitious program ever to be undertaken by India. India's indigenous human spaceflight program. The question is, has an Indian ever gone to space? Answer is yes, Rakesh Sharma. But has an Indian ever gone to space in an Indian launch vehicle launched in India? Obviously, answer is no. Okay. So Rakesh Sharma he was Wing Commander Rakesh Sharma. He had gone to space on 3rd April 1984. And at that time, we had a very strong cooperation with the Russians. And he, along with Russian cosmonauts, blasted off from the Baikonur. So Baikonur is erstwhile USSR. Baikonur is erstwhile USSR, but now it is a part of Kazakhstan. Yeah, so technically it's not in Russia, it's in Kazakhstan now, after the disintegration of the USSR. So Soyuz T-11 was the launch vehicle. As you may be aware, or you must have seen the video recordings also. So when the Prime Minister Indira Gandhi asked Rakesh Sharma as to how does India look from space, so he's stated to have said, "Sare jahan se acha Hindustan hamara." So, which is, the Muhammad Iqbal's famous line. Okay, so now let's look at and so Rakesh Sharma is only Indian, but if you look at Indian origin people who have gone to space, there are plenty of them. One was this unfortunate case of Kalpana Chawla not making it back, but you also have people like Sunita Williams who've gone to international space stations, have gone on multiple missions. Yeah, so if it is of people of Indian origin who have gone to space, you have a couple of names. If you look at Indians who have gone to space, it is only Rakesh Sharma. Currently, we are hoping that in the next year or so, we should be able to send a crew of 3 Indians through India's indigenous launch vehicle, which is going to be GSLV Mk3 Mark III, and they would be in space for approximately 1 week. So there is a lot of tests that has already gone. There's a test that is going on. There's been budget or funding that has been approved. A lot of things that have happened. Now I want you to look at GAGANYAAN at 3 broad categories. Okay, first is the crew module. This is by far the most important part of GAGANYAAN. Why do I say this is the most important part of GAGANYAAN? Is the launch vehicle is more or less ready, because the GSLV Mark III is capable of launching something like 10 tons. It was very clear that the crew module is coming within 10 tons. So the launch, readiness of the vehicle can be done. Training of crew members, we have a lot of cooperation. We have some experience ourselves, but we have the Russians to depend upon, and not just Russia. France has also stepped in to help with their knowledge of space medicine, so on and so forth. So this is also important, but it is doable. But what is really important is the crew module, which is, when I say crew module, it's nothing but the room. Let me say room, yeah, a capsule or a room in which the 3 astronauts will spend 1 week in space at an altitude of 400 kilometers. Now imagine, maximum emphasis has gone into designing a crew module which can survive, withstand the time in space, can withstand another very dangerous phenomena which we will discuss in detail, called as re-entry. RE and entry, re-entry. So we'll discuss all these terms one by one. Is it that India is preparing for GAGANYAAN now? No. Indian preparation for GAGANYAAN started way back in 2007, which means 15 years before itself, we started some parts. It always happens, no? When a task is very complex, you divide it into small parts and you gain confidence little by little. That's exactly the approach that India has followed, starting with the Space Capsule Recovery Experiment 2007, followed by Crew Module Atmospheric Re-entry Experiment. So this is also called a CARE, Crew Module Atmospheric Re-entry Experiment. And the most recent was testing of the Crew Escape Module. It was also called as the Pad Abort test, if you remember it. Yeah, that was in 2018. So let's look at the testing of the various crew modules. Let's look at all the tests one by one. Space Capsule Recovery Experiment 2007. This capsule that you see on the left side that is kept at display in one of the ISRO centers, it remained in orbit for 12 days before re-entering the Earth's surface and splashing down in Bay of Bengal. Now, when the humans go to space, yeah, think about it carefully. When the human goes to space, what will happen? They will be inside, means they are the payload. The crew module is the payload, or the satellite equivalent, if you may like to think that way, which will be inside the launch vehicle. The launch vehicle will lift off. Then it will place the crew module at 400 kilometers, which is incidentally the same distance of the International Space Station. There, the crew module, what will it do? It will orbit around the Earth for 7 days. The crew will perform certain experiments, and after 7 days, it will, through some series of maneuvers, which I will discuss shortly, will come to a particular height. So from 400, it will come step by step up to around 80 kilometers. From 80 kilometers, it is just a drop down, a splash, a controlled splash through a series of parachutes. So it's quite an audacious, I would say, endeavor or an experiment, because you're going to have the human lives inside that. Okay. Now, in the space capsule recovery experiment, what part did we test? We tested the part whether the crew module could be in orbit for 12 days. Our actual requirement is 7 days, but they made sure it is there for 12 days. So that was tested. That was tested. Now, while it was in the orbit for 12 days, there were a lot of experiments on microgravity, thermal protection, and some of the other data that was taken. For example, one of the data that would be taken, I can tell you for sure, is that when it re-entered the atmosphere, I'll tell you what is the meaning of re-entry. When it re-entered the atmosphere, this module experiences enormous amount of heat. You may say, why heat? Heat due to friction. But if you ask what is there for friction, unbelievable as it may sound, air causes friction. Does really air cause friction? It does when something is traveling at an enormous speed. Okay. Therefore, you need heat shields. Heat shields, SHIELDS, heat shields, to protect the people inside. In fact, what you're seeing here, this brown colored tile-like thing, these are heat shields only. Okay. So what we did way back in 2007, we tested that, okay, this module can orbit, and it has also re-entered. Now, not satisfied with that, we did a dedicated experiment, this time focusing only on the re-entry, because going to space and coming back is like, in my view, is like entering a chakravyuh. It's easier to get into the orbit. It's difficult to come out of the orbit and come back to the surface without alive. Yeah. And one of the most painful memories is that of Kalpana Chawla and her fellow astronauts who were killed in one of the attempts of discovery. If you look at the videos, you can look at it. The problem was during re-entry, what happened when they did the root cause and during re-entry, few of these heat tiles, what they did not realize, when the rocket had taken off, some of these heat tiles had already broken off. Because some of the heat tiles were broken off, the heat was able to go directly into the metal part. And the metal melted and it just blew into pieces. Yeah, nothing could actually be recovered. Okay. So, 7 years after doing the space capsule recovery experiment, in 2014, India started the next experiment specifically to test the re-entry. Okay, so the rocket blasted off, it did maneuvers, and it re-entered at 80 kilometers. So in this case, since the purpose was only re-entry, unlike the previous time, the height was not too much. Okay, because the space capsule recovery experiment, it was in orbit for 12 days. So they had to raise it to 200, 300 or 400 kilometers. But in this case, the whole experiment is about re-entry. Re-entry is at atmospheric level. So what they did was something like this. So you have what is called as a sensible atmosphere at 90 kilometers. So the launch vehicle went at around 120 kilometers. Yeah. And after 120 kilometers, it kind of made some maneuver between 120 to 90 kilometers, came down slowly, and from here onwards, it was a direct splash down. So a lot of interesting data was captured. One thing that was captured was the deceleration. One is acceleration, another is deceleration. Yeah. Now, when the capsule was at 120 kilometer height, yeah, it was going at a very, very fast pace. Okay. So they somehow, after it came down to 90 kilometer, they started deploying, if you can see this, they started deploying parachutes way before that. Because of the parachutes, there is a sudden deceleration. Are you able to understand? Because there is an opposing force. You are falling at a very fast pace. Now, suddenly the pace is reducing rapidly. So they experienced 13 G force. Now, that's a lot of force. 1g is 9.8 meters per second squared. So 13 times that acceleration the systems had felt, which means if an astronaut was inside, he would have felt this. Now, whether he will be able to survive this, I think that was the study that they are doing. Now, the second thing that they found out, so this is one problem to solve. Is there a way we can reduce this G-force? The second problem to solve was temperature going up to 1000 degrees Celsius. Very comfortably, temperature reached 1000 degrees Celsius. Okay. Now, as I said, from 120 kilometer till about 40-50 kilometers, or maybe till about even 5 kilometers, there were a series of parachutes. So there was a 3-stage of parachute, which was progressively reducing the speed of the crew module as it splashed. As you can see here, the Coast Guard people are trying to tow this away from its point, and this was eventually brought and kept in Bangalore also. Here also you can see this orange color over here. Yeah, so this, and you can see it as a tile. Right, it looks like a tile, right? Yeah, it looks like a tile because it is called as a heat shield itself. Okay, and yeah, so these are some of the salient features about the crew module atmospheric re-entry experiment. So what we did, let me go back. We started with space capsule recovery. So in space capsule recovery, the main aim was orbit. The main aim was orbit. Whether it is able to have an orbit. Sorry. And crew module, the main aim was re-entry. Now comes the third part. What if during the launch, the rocket fails? Means instead of going up, it goes up and then comes down. What happens to the astronauts there? They are locked inside the launch vehicle. What will they do? The third test was precisely for this kind of scenario, which they called as the crew escape module. Crew escape module. Now, what is a crew escape module? In case of emergency during launch, so please understand, this module will work only in the first and the second stage. So when a rocket is launched also, there are several stages. So this crew module will work up to the first 4 to 5 minutes of the rocket launch. Yeah, till then, if something bad happens, then this crew module has its own separate set of boosters, which will propel it away from the rocket. So it is like the fighter aircraft eject seat, if you have seen. Before the fighter aircraft crashes, the pilot is able to eject himself from the fighter aircraft and save himself. Okay. So this again was successfully tested in July 2018. So if I can summarize, we have tested the safety, or we've got enough data points of the orbits through the first experiment called the space capsule recovery experiment. We've got enough data point on the re-entry, which includes the type of gravitational force that the astronauts have to suffer. In this case, it was calculated to be 13G, which is very high, by the way. The fighter aircraft pilots experience around 6 to 7G. Okay, so this is twice what a fighter aircraft pilot can experience. Whether the human body can take it or not, I don't know. And they also looked at the temperatures at the heat shield. So it's 1000 degrees. So once they get all this, it becomes really easy for them to design. No, they'll say, okay, 1000 degrees is the maximum it has gone. Therefore, we have to have a heat shield which can comfortably work in 1500 degrees. We'll put a margin of safety there. You will figure out that, oh no, 13G is too much. At the max, we can go 8G. So if it is 8G, what should we do? What kind of parachute be deployed? At what height should it be deployed? Can we reduce it, a little bit more, so on and so forth. So this 3 parts completes our the testing of crew module. Yeah, we have just completed this part. Now let's move on to this part, the readiness of the launch vehicle itself. Here, let us discuss some of the salient features of GSLV Mark III. So as I said, GSLV Mark III is the real workhorse of ISRO. Heavier the payload, more suitable is it for GSLV. So GSLV Mark III is designed to carry 4 tons of satellite into the geosynchronous transfer orbit. Now are you able to understand geosynchronous transfer orbit, which eventually will become geostationary orbit, or about 10 tons to LEO, low Earth orbit. Now, as we know, GAGANYAAN is in low Earth orbit, so we can go up to 10 tons. We can go up to 10 tons. Let's trace the journey of GSLV Mark III, or the key highlights of GSLV Mark III. Now, there were 2 points. The first is called as an experimental flight. The second is called as a development flight. Experimental flight is you are testing the launch vehicle itself. Okay, so they have this abbreviation LVM3. So what does this mean? Launch Vehicle Mark III, which is somewhat this. Yeah, somewhat this. This part is Launch Vehicle Mark III. X means experimental. Care is what we discussed about the crew module atmospheric re-entry experiment. So this part we have already discussed. So now, on one hand, you're testing the crew module. On the other hand, you're also testing the launch vehicle. So in a sense, two objectives getting merged in one. Objectives getting merged in one launch. Then you have the first developmental flight. The first developmental flight, 14 was an experimental flight. 17 was the actual developmental flight, where we have placed GSAT 19. So now what you're doing with every launch, your confidence level improves. Then came your second developmental flight. You launched GSAT 29, a high throughput communication satellite. Then came your big leap, launching Chandrayaan 2. So imagine, this is a kind of test that ISRO does. It is no more it's not just a simulation, it is actual launch. Not 1 or 2, but 4 launches, and 4 different launches with increasing complexity, the most recent being of Chandrayaan 2. Now GSLV Mark III to that extent is now fully ready to launch the crew module. Let's look at it. So that's about GSLV Mark III. Now the third part of the launch is what I call as the training of the crew members. This is also important, right? Of course, you may say, no, sir, we also need budget, we need timeline, all that is true. Budget and all has been approved. We will discuss that part also. So training of crew members and the other aspects, salient features of the GAGANYAAN, we will discuss it now. So the government has approved 10,000 crores for this project in 2018. And this is an endeavor where multiple organizations come together. For example, I forgot to add this. So this crew module has a good amount of input from Hindustan Aeronautics Limited. ISRO anyway is involved. DRDO's expertise has been sought for certain critical areas: space grade food, crew healthcare, radiation measurement, parachutes. So you have HAL, you have ISRO, you have DRDO, you also have the Russian Space Agency, you also have the French Space Agency. At least these are the known ones. If there are more help, I don't know if Israel or some other country is doing, at least not that has been officially mentioned. So what will the crew do in space? So the crew, what experiment they have to do has also been decided already. They'll perform 4 biological and 2 physical science experiments related to microgravity. And one important organizational change that has happened is ISRO has opened a dedicated human space flight center. So this is the nodal agency within ISRO to coordinate all activities of GAGANYAAN. So this human space flight center and Glavkosmos, which is a Russian agency, they have signed an agreement for training of Indian astronauts. Because Russia has launched man into space several times, therefore they will be in a better position to help us understand what the human body undergoes, what kind of diet they should do, how should they sleep, when should they sleep, do they get sleep at all, what is the impact of weightlessness on blood pressure, on heart rate. They will have to really do a lot of experiments. And since Russia has already done these several times, we are partnering with Russia for these experiments. Okay, so that's on some of the key features. For a long time, it was thought that we may have around 2 to 3, but that's now more or less settling to 3%. 3% in space. And there is a continuous testing happening on recovery system, crew escape system. How will life control? Because you need oxygen. How are you going to have oxygen? What is the mechanism for respiration? 7 days is not a short time. Yeah, you actually have to live in space for 7 days. Yeah, one interesting fact that I would want to highlight is that we have always talked about the crew module, which is 5 tons, but there is also what is called as a service module. Okay, so both these crew and service modules will be docked together, and both of them will be circulating around the Earth. And together it comes to 8.2 tons, which is within the capability of the GSLV Mark III, which can carry up to 10 tons. Okay, so for this launch, there is a proposal to have a separate launch pad. The Satish Dhawan Space Center or the Sriharikota Center currently has 2 launch pads. There is a proposal to build a 3rd launch pad exclusively dedicated for GAGANYAAN. Okay. Now, where do we stand when we compare to the other countries? So, if you are able to send a man to space successfully and bring them back successfully, then we would be the 4th nation after Russia, US, China to have carried out manned missions indigenously. Is China ahead of us? It is. So China is at least 6 to 7 years ahead of us, because in 2016 it sent 2 astronauts on a fairly long manned mission to space, and it is also working to have a space station. There is already an international space station, but China wants to have its own space station. Okay, so this is where I would like to stop today's class, in which we have primarily talked about the human spaceflight program, and I had touched upon the IRNSS and the GAGAN. In the next class, I will dedicatedly deal with India's tryst with with extraterrestrial exploration, which will be on celestial bodies like Moon, Mars, Sun, etc. Yeah. So I'll come back with speaking with you on these topics very soon. Till then, please do go through this video and share with me your doubts. When we meet over our class, usual class, I'll spend the first few minutes clearing some of the doubts that you may have. Thank you so much.